topics as we go through. So today is mostly review. You have done systems of equations before. In Algebra 1 and Algebra 2, you talked about solutions to systems of equations. We are going to expand on it a little bit. Tomorrow we'll talk about nonlinear systems. I think you guys have only done linear systems or the nonlinear when you were looking at a graph. But we're starting with things that you should already know. Couple things terminology-wise when we're talking about a system of equations. The solution is just whatever ordered pair makes them both true. If it has a solution, we call it consistent. So today we're looking at two lines. So we know if we have two lines, they meet in a single point. The solution is that point. Because we have a solution, we say they are consistent. Or it's possible that you might have two equations that turn out to be the same line when you graph them. In which case, every point on that line is the solution. But again, if you can get a solution, it's consistent. When there is no solution, we call it inconsistent. What would the graph look like if there was no solution? Two lines that don't intersect, so they have to be parallel. So parallel lines never meet. That would be an inconsistent system. When you first started solving these, you did it by graphing. So you would graph both lines and then find the point where they meet. The downside to graphing, your graphs had to be perfect for you to find that. And it also was really hard if your intersection was like -1/8, -1/4. That's really hard to tell from a graph. So we're really not going to use graphing as an option. We're just going to stick with substitution and elimination. So we'll do a couple examples of each, review those, and then talk about a couple special cases. So if I told you to solve this by substitution, what does substitution mean? Do you guys remember? So we have to start with one of the equations, solve for one of the variables, and substitute it into the other one. It doesn't matter at all what you want to solve for. So maybe I decide I want to solve for x in the second equation. If I want to get x by itself, we would add over the y. So x is 4 plus y. So I got that from the second one. That means I have to sub it into the first equation. So the first equation is x plus y equals 8. But what am I replacing my x with? 4 plus y. We combine my terms. 4 plus 2y equals 8. So 2y equals 4. Divide and y is 2. All right, your answer is an ordered pair. So when I look at this, I have y, now we need x. So you can plug it back into either the original or just right here. We know x is 4 plus y. So if I put it in there, 4 plus 2 is 6. And answer, we write it as an ordered pair, x, y, so 6, comma 2. So if we had drawn a graph, that would be the point where they meet. Questions there? You can always check these. 6 plus 2 is 8, 6 minus 2 is 4. So we do get that solution. Let's try one more substitution. On this one, what would it be easiest to solve for? The y in the top one. That way you don't have any fractions. And so if I do that, I just have to subtract over the 2x. So y is 5 minus 2x. So then we sub it into the other one. The other one is negative 4x plus 6 times, what is our y? plus negative 2. So if we distribute, we get 30 minus 12x. Negative 4x, negative 6, or negative 12x, negative 16x. 30 equals negative 2. Subtract the 30. Divide, and x is 2. So plug it back in. The easiest is the equation where we already solved for y. So if we put that in, 5 minus 4 is 1. And my point is 2, 1. And you can check it if you plugged it in. 2 times 2 plus 1 is 5. Negative 4 times 2 plus 6 is negative 2. Are those okay? Alright. So we understand substitution, remember that? Okay, let's run through elimination. So if I ask you to solve this by elimination, the idea behind elimination is you want to add your equations together and get one variable to cancel out. Now if I just add them right now, nothing cancels. They cancel if their coefficients are the same number but opposite signs. So to get there, we usually pick an equation and multiply by something. Sometimes you might have to multiply both. Do you want to cancel x or y? Okay, so if I want to cancel y, what would I have to multiply the first equation by? If you had chosen to cancel x, what would you multiply by? Probably just positive 2, because you already had the negative 1. Okay. So we get negative 12x and 6y equals negative 30. Negative 4x plus 6y equals 12. When we add negative 12 plus negative 4 is negative 16x. The y's cancel. So when you divide, negative 18 divided by negative 16, 9/8. Don't assume you're wrong just because you get a decimal or a fraction. It can happen. So now to get y, we just plug this back in, either equation. So if I just go with the top, so 2 times 9/8 is 9/4 plus y equals 5. Subtract your 9/4 over. You get 11/4. And you can always check just by putting them back into the original equation. You guys think you can try one? Variable, did you eliminate? Okay, so if I want to eliminate x, I could just take this 1 times, probably just positive 2 because it's already negative. If we add this together, we get 5y equals negative 5, and y is negative 1. Is everybody with me? Audrey, why don't you put that away until I'm done? So then, you can plug that back in, either equation. So if I just go with the top one, so we get 2x minus 3 equals 1. So 2x is 4 and x is 2. Sometimes you might have to multiply both equations by something to get them to cancel, but the strategy is still the same. We're just trying to get opposite signs. we okay with elimination? I'd like to do 2 more problems just looking at a couple special cases. Let's say maybe this. So 2x plus y equals 5, and 4x plus 2y equals 8. If I want to, which variable do you want to cancel? X. If you want to cancel x, what do you have to multiply by?
Cancel both of them out.
To do that. Positive and negative 4x cancel, positive and negative 2y cancel. So we get 0 equals negative 10 plus 8 is negative 2. Does 0 equal negative 2? So what does that tell me? No solution. On these problems, it will always say in the directions, if the system is inconsistent, say so. No solution means inconsistent. So when that happens, you have to write inconsistent along with it. And so that's when you eliminate and you're left with a false statement. 0 equals a number. Is that okay? I gave you this one. Alright, if I want to cancel x, what would we have to multiply by?
Negative 2. For the top one.
That would give me a 2/3.
Okay.
So, but think along those lines. First, to cancel the fraction, you'd have to multiply by 3, right? And then we need it to be a negative 6. What would I have to multiply by?
Negative 18.
Negative 18. Or positive 18, so we already have negative. If you're not sure, you just divide them. So you divide the coefficients. Negative 6 divided by 1/3 gives you 18. So that's what we need to divide by, or multiply by. So if I distribute my 18, I get 6x plus 3y equals 12. And negative 6x minus 3y equals negative 12. When I add, the x cancel, the y cancel, so I get 0 equals 12, and negative 12 is 0. Okay, it's not no solution because this is true. 0 is equal to 0. What that means is they were the same line. I think in the past you wrote infinite solutions. But the problem is it's not really any ordered pair that I picked. That's a solution. It's just the ones on the line. So now you're going to be told how to write your solutions. So I might say write it with y arbitrary. That means in terms of y. So we know an ordered pair is x comma y. If I'm saying in terms of y, we keep the y as it is. But I have to come up with an expression for my x. So we're going to go to one of these equations, and we're going to solve for x. So if I took the second one. If I wanted to solve for x, we could add over the 3y. To get x by itself, divide by negative 6. So x is 2 minus 1/2 y. So my expression for x is 2 minus 1/2 y. So if it's infinite solutions, you are going to have to give the ordered pair in terms of one of the variables. If I had said to make it in terms of x, that would mean you would keep the variable x and you would go to your equation and solve for y to figure out what y is. So that is really the only new piece today. Are there questions on this? We have quite a bit of time. There's a Math Excel assignment open. So you guys can start working on that and let me know if you